Good morning, students. Let us quickly see the important points of this chapter. So, this chapter is all around free electrons in a conductor. Free electrons in a conductor give rise to electric current in a conductor. In the absence of electric field, the net drift velocity of all the electrons in a conductor is 0, and in the presence of electric field, the average velocity of the sample of electrons is drift velocity, and drift velocity is equal to minus E tau by m. It is directly proportional to average relaxation time, that is the average time between two successive collision for a number of electrons in a given sample of conductor. M is the mass of electron, E is the electric field. There is one more relation for this current and drift velocity. Current I is equal to NA Vd, where N is the number density. Number density means number per unit volume. E is the charge, A is the area of cross section, and Vd is the drift velocity. Okay, then we have seen Ohm's law. V is equal to IR, where V is the potential. That is, potential difference across the ends of a conductor is directly proportional to the current flowing through it if external conditions are kept same. And if a graph is drawn between V and I, it will be a straight line for ohmic conductors, and for non-ohmic conductor, it will not be a straight line. The slope of this line gives you the resistance. You can calculate the resistance if a straight line graph is given between V and I. Okay. A negative slope of Vi graph means that resistance is negative for that point. Also, we have seen Ohm's law in vector form. In vector form, we can write J is equal to sigma E, where J is the current density, that is current per unit area of cross section through which that current is passing. Sigma is the conductivity, which is reciprocal of the resistivity. E is the electric field. E is the electric field. So both of these are vectors. J is vector, E is vector. That's why this is Ohm's law in vector form. Okay, and we have seen that R is resistance, which is the obstruction to the flow of current or opposition to the flow of current, and resistance is equal to rho L by A. It is directly proportional to length of the conductor and inversely proportional to area of cross section. And this is proportionality constant that depends on nature of material and temperature. Resistivity depends on these two factors. SI unit of resistance is ohm and resistivity is ohm meter, or these resistances can be in series combination or in parallel. In series, the equivalent resistance is given by summation of all the resistances. In parallel, the equivalent resistance is given by 1 by R equivalent is equal to summation 1 by Ri. Ri means 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Okay, then we have seen what are the factors on which this resistivity depends. So resistivity mainly depends on this temperature, and if we increase the temperature, then resistivity of conductors increases, and this resistivity can be related with temperature as given by this relation. Rho is equal to rho naught 1 plus alpha delta T, where rho is the resistivity at some temperature T, rho naught is the resistivity at some given temperature, alpha is the coefficient of conductivity, temperature coefficient of resistivity, and delta T is the difference in temperature, that is T2 minus T1. Okay, we have seen that resistivity of conductor is least, then alloys, then semiconductor, and then insulator. Also, we have seen some graphs. For conductor, the graph of resistivity with temperature is just increasing curve like this, and for alloys it is nearly a straight line like constant in manganese. That's why they are used in making standard resistors. For semiconductor, the graph is decreasing like this, a curve which is decreasing with the temperature, and same for the insulator. Then we have seen the relation for power and energy. We have seen Joule's law of heating, that H is equal to I square RT. Heat produced or energy produced across a resistor is directly proportional to square of current, directly proportional to resistance, and directly proportional to the time for which the current is flowing. Also, we have derived a relation for power, that is P is equal to V square by R or IV or I square R. Then we have done some numericals on all these concepts. A lot of numericals have been done in our class, and after that we have started this very important topic, that is cell EMF and internal resistance. I have told you what is a cell. A cell is a device which can convert the chemical energy into electrical energy, and in doing so it is able to pass some current through the circuit. What is EMF? EMF is the maximum potential difference between the two electrodes of a cell when there is no current in the circuit or if the circuit is open. Then I have told you internal resistance. It is the resistance of electrodes and the electrolyte which is filled in the cell. And one more thing was there, that is terminal potential. Terminal potential is the maximum potential difference between the two electrodes when the circuit is closed or when current is passing through it. A relation was there between EMF, this terminal voltage, and internal resistance, that is V is equal to E minus IR. So in case of discharging of a battery, EMF is always greater than potential difference, because some of the potential has been dropped on internal resistance, so we get a less potential difference across the terminals when the current is flowing through it. Okay, so also we have seen two cells in parallel series, their combination, and how to derive a relation between them. Then we have seen Kirchhoffs rule. There were two rules. One was Kirchhoffs current rule and another one is Kirchhoffs voltage rule or loop rule. Current rule was that at a junction the total incoming current is equal to the total outgoing current, and that rule is directly follows from conservation of charge, and Kirchhoff voltage rule directly follows from conservation of energy. Kirchhoff voltage rule simply says that sum of all the potential differences in a closed loop, that is EMFs and a drop across resistors, is always zero, and it is a direct consequence of conservation of energy, because work done in a closed loop is zero for conservative forces, and as we know electric field is conservative in nature, so that's why in a closed loop work done is zero, and work done is directly related with the potential. So that's why if work done is zero in a closed path, then sum of all the potential differences must be zero in a closed path. Based on this we have done 4 or 5 numericals which are very important. इस पूरे चैप्टर से जितनी भी वीडियोस मैंने अपलोड की हैं आप उनको एक बार देखिए, और लास्ट में मैंने आपको व्हीटस्टोन ब्रिज के बारे में बताया था. लास्ट क्लास में व्हीटस्टोन ब्रिज में मैंने आपको बताया था इट इज़ एन अरेंजमेंट ऑफ 4 रेजिस्टर्स which are arranged in 2 arms and a galvanometer bridge the gap between the 2 arms. That's why its name is Wheatstonebridge. Okay, named after the scientist Charles Wheatstone. Okay, and we have derived a condition for it, that for balanced Wheatstonebridge the resistance in the 2 arms must be in equal ratio, that is R1 by R2 must be equal to R3 by R4. We have seen a derivation for that also. Okay students, so I hope ये बताने के बाद आप खुद से एक अपने आप से, मेरी आप सबसे एक रिक्वेस्ट है कि आप इसको मत कॉपी करना. आप चैप्टर को पढ़ने के बाद खुद से एक माइंड मैप तैयार करेंगे स्टूडेंट. देखिए आप जब तैयार करेंगे उस चीज़ को तो आपको लॉन्ग लास्टिंग याद रहेगा. इसको कॉपी करने का कोई फ़ायदा नहीं है. ये वैसे भी मेरे पास कम जगह है तो मैंने थोड़ी सी जगह में कम कंसेप्ट्स लिखे हैं. आप एक कॉपी के 2 पेज यूज़ कर सकते हैं, और 2 पेजों पे आप चैप्टर के बिल्कुल स्टार्टिंग से जो कंसेप्ट मैंने पहले दिन आपको बताए थे वहाँ से शुरू करके लास्ट जो आपका टॉपिक आ रहा है टेस्ट के अंदर, वहाँ तक आप उसको छोटा छोटा करके लिखिए. बिल्कुल 2 पेज में आपकी जितने कंसेप्ट है सब उसमें आ जाने चाहिए, और उसको देखते ही आपको चैप्टर के बारे में पता लग जाना चाहिए कि आपने क्या क्या पढ़ा है। वो आपको बहुत ज़्यादा बेनिफिशियल रहेगा। मोर इम्पोर्टेंटली एट द टाइम ऑफ एग्ज़ाम, जब आपका एग्ज़ाम होगा तो उस टाइम आपको बहुत ज़्यादा हेल्प करेगा स्टूडेंट्स वो। सो आप इसके बारे में पढ़िए और आई होप अब आप सब रेडी होगे एग्ज़ाम के लिए। तो इस वीडियो के बाद, देखने के बाद आपका एक एग्ज़ाम होगा दैट इज़ ऑफ 10 ऑब्जेक्टिव क्वेश्चंस, और आप उनमें से कोई भी एक जो ऑप्शन करेक्ट है वो टिक करेंगे। ओके स्टूडेंट्स, थैंक यू।